Our last part of the lecture here in Module 12, we're going to talk about graphing with transformations. And so you see a table here. We have all of the different transformations listed. So we'll deal with a parent exponential function and a parent logarithmic function. Of course, the base a can be any value. And all of these functions have an xy ordered pair. So we're just going to refresh our memory and make sure we know what all these different values that we add, c, b, h, and k, are going to do to the function. So if you multiply by some value c, multiplying by c on the outside, that is a vertical stretch or compression by c. So we're going to multiply the y value by c. However, if we multiply by a value on the inside, so notice these b values here when we look at the third row, my b values are on the inside of the exponent or the inside of the argument, right? So multiplying on the inside is horizontal. And remember, horizontal does the opposite of what we think. So it's going to be a stretch or compression, but we're actually going to take x and divide by b. So on the row above, we multiplied by c on the y. Here we're dividing by b on the x. If you multiply by a negative on the outside of the function, you're going to reflect across the x-axis. That's outside, so that would be a vertical reflection. However, if you multiply by a negative value on the inside, and that's attached to x, that's going to reflect across the y-axis. That's a horizontal reflection, and you'll notice we have negated the x and y in our ordered pairs, respectively. Adding a value on the outside, that would be a shift up or down. So plus minus k, that is a vertical shift, and we would add or subtract k to the y. And then lastly, adding h. So adding h on the inside or subtracting h on the inside. And what you want to notice is that we are going to do the opposite. We're going to, if it's adding on the inside, we're going to subtract that h value from x. And if we're subtracting on the inside some number from x, we're going to add that to x in our ordered pair. So let's apply this and figure out some of these transformation graphs. So we're starting off with an exponential function here. It is an exponential function. My base is 1/3. And because that base is less than 1, we know it's going to be decreasing. Okay? So the parent for this exponential would just be the very most basic. We would just have y equals 1/3 raised to the x. And using our ordered pairs for parent functions, we're always going to have -1, 0, 1. And I would say 1 over a, 1 over 1/3 gives me 3. Then we get 1. And here we just have our a value, which is 1/3. So that would be our parent graph. Plotting those points, we have 0, 1, over 1 up 1/3, left 1 up 3. So it's very similar to what we graphed before when we did base of 1/2. Okay, but we have some transformations, and what we want to notice is there's a negative in here in front of the x, and there's also a -1. So the negative in front of the x, what does that do? That's going to cause the graph to reflect. Multiplying by a negative causes a reflect, and since it's multiplying by x, that's going to be a horizontal reflection, and if you reflect horizontally, we're going to go over the y-axis because the y-axis is vertical. And then the -1 lets us know we're going to shift down 1 unit. So what does that do to my ordered pairs? It takes my x's, and I'm going to multiply my x's by a -1, and my y values, I'm going to take them and subtract 1. So -1 times -1 is 1, 0 times -1 is still 0, and 1 times -1 is -1. 3 take away 1 is 2, 1 take away 1 is 0, and 1/3 take away 1 is -2/3. So graphing my transformed function over 1 up 2, 0, 0 at the origin, and -1 down 2/3. We have a graph that looks roughly like this. So what does that do? Originally, our asymptote for this function, we had a horizontal asymptote at y equals 0. The domain was all real numbers, and the range was 0 to infinity. But what did those transformations do to change that asymptote and domain and range? Well, the domain is still -infinity to infinity, but we shifted down 1 unit. And shifting down 1 unit means that asymptote moved from 0 down to -1. And my range also is going to become -1 to positive infinity. So we see that asymptote is right there. Instead of in the original, we had it at 0. All right. So let's do one more exponential, and then we've got 2 logarithmic graphs. So here we have an exponential. It's base e. And we've got lots of values applied to it that are going to create transformations. So let's just think about what our parent function would look like. That would be y equals e to the x. And my parent ordered pairs, I would have -1, 1 over e, 0, 1, and 1 e. So what this looks like, and remember e is approximately 2.718. So -1, 1 divided by 2.718. We have a positive fraction here. And I've got 0, 1, and over 1 up e, about right there. So here's my parent function. Again, it has a horizontal asymptote at y equals 0. The domain is all real numbers, and the range is 0 to positive infinity. So let's break this down and look at the values and what those are doing. So I have a -2e to the x minus 1 and a +3. So multiplying by 2 is going to cause it to stretch vertically, and multiplying by the negative, the fact that that 2 is negative, is going to cause a vertical reflection. So we'll say that it reflects down over the x-axis, and it's going to stretch vertically by a factor of 2. So the 2 caused it to stretch, the negative caused the reflection. So when we're multiplying, if we multiply by a negative, there's going to be a reflection. E to the x minus 1. So that minus 1 is attached to x. Remember, when things are attached to x, they're always going to behave the opposite. So this is going to cause it to shift. We'd think negative would go left, but we're going to shift right 1 unit. And lastly, the plus 3, that's added on the outside. We're going to shift up 3 units. So my ordered pairs here for x, I'm going to take that x value and I'm going to add 1 to it. So all of my x's, I would add 1. So negative 1, if I add 1, I get 0. 0, if I add 1, I get 1. And 1, if I add 1, I get 2. My y values, I'm going to take my y and multiply it by negative 2, and then I'm going to add 3. So when I take this, I multiply it by negative 2, it comes over here. That's going to be negative 2 over e plus 3. Here, 1 times negative 2 plus 3 gives me 1. And then lastly, when I do that, I have negative 2e plus 3. Which those are approximate values. I can type those into my calculator using my E button as I need to. So we'll plot those points. Negative 2 over E plus 3 is a little bit above negative 2 right here. And then we have an ordered pair at 1, 1. And negative 2e plus 3, type that number in your calculator. You get approximately negative 2 and change. So we get a graph that's about right here. All right, so what happened to the asymptote, the domain, and the range? The asymptote shifted up 3. So my asymptote became y equals 3. My domain didn't change at all. My graph still spans from the left and the right forever. However, my range changed. And not only did it shift up 3, but we had that vertical reflection. So now it's going from negative infinity to 3. As opposed to 0 to infinity. All right. Right, example 10, we're going to graph a logarithm. So again, we'll talk about our parent, and the parent here is base 4. So we have y equals log base 4 of x. And my parent ordered pairs would be 1/4, negative 1, 1, 0, and 4, 1. So what that graph looks like if I plot these. It has a vertical asymptote at x equals 0. There's a domain restriction, so this only graphs from 0 to positive infinity. And then the range is all real numbers. All right, so this is what our parent function looks like. Now, we're going to examine what all of the transformations look like. One thing I know we haven't talked about yet is graphing something that is not base E or base 10. So your calculator has two buttons. It's got log and it has an ln, right? ln is base E. The log button on your calculator is base 10. So in order to type this in the calculator, if you were trying to do that, you'd need to use the change of base formula. So the change of base formula says that if I want to type log base b of m, I could type that in my calculator as ln m over ln b. So log of the argument over log of the base, or natural log of the argument over natural log of the base. And you can use either of those two buttons on your calculator. So if you were trying to type this parent into your y equals, you might go to your y1, you would have to type ln x, and it's going to open and close parentheses, divided by ln 4. And that would be how you would be able to achieve seeing that picture on your calculator. So let me just make that go away. I'm actually going to pause. So we talked about that change of base formula, and if you didn't get it, pause the video, rewind it, make sure you know that. But that's how you can type anything in your calculator to graph that's not base 10. So let's talk about the transformations. We have this minus 2. We have this negative in front of the log. And we have a plus 3. And if I rearrange this and kind of put it more in the standard form we're used to seeing, this is the same as saying y equals negative, let me use color, we'll say negative log base 4 of x plus 3 minus 2. So what does the negative do? Multiplying by a negative on the outside, we're going to reflect down over the y-axis. It's a vertical reflection across that y-axis. The plus 3 is going to cause us to shift. When we're adding, it causes a shift. And because it's on the inside, it's horizontal. So it's either left or right. Remember that when you shift horizontally, you're always going to move the opposite of what you think. So we're going to shift left 3 units and down 2 units. So my x value, if I were to write this here, my x value would change because we would say x minus 3, and my y value would change because we would have negative y plus 2. So take 1/4, subtract 3, you're going to end up with negative 2.75. 1 take away 3, negative 2, and 4 take away 3 is 1. And so when we do our y's, and I'm noticing I put a plus 2 because we said minus 2 and shift down, that should be a minus 2 there. So negative y minus 2, negative negative 1, take away 2 is negative 1. 0, take away 2 is negative 2. And negative 1, take away negative 2 is negative 3. So if we go to plot these points, we're over at 2 3/4 negative, down negative 1. Negative 2, negative 2. And positive 1, negative 3. So my graph runs through these curves and goes up right here. So what we can see is now that this guy has a vertical asymptote at x equals -3. So it's shifted left 3 units. And my domain is -3 to positive infinity. And the range in this situation stays the same, -infinity to positive infinity. Okay, our last graph here ln equals -x plus 4. The parent and the base on this graph is e, so my parent graph is y equals ln x. My parent graph ordered pairs would be 1 over e, 1, and e, -1, 0, and 1. So the graph of natural log x looks like our standard logarithmic exponential or Euler's value graph, natural log graph. It has a vertical asymptote at x equals 0. The domain is 0 to positive infinity, and the range is all real numbers. So we have 2 values that are added to this parent that change it. We have a negative in front of the x and a plus 4. And what that negative does is that is going to create, it's going to cause this graph to reflect horizontally. And reflecting horizontally, we're going to reflect over the y-axis. A horizontal reflection goes across our y-axis. And then we're going to shift up 4 units because that 4 is added on the outside. It's a shift because of the adding outside vertical, so we're going to go up 4. So my ordered pairs, that's going to negate my x's, and we're going to add 4 to my y's. So negating my x's, I get 1 over e, negative, 1, negative, and e, negative. And then taking my y values and adding 4 to them. -1 plus 4 is 3, 0 plus 4 is 4, and 1 plus 4 is 5. So if I am to plot my points, I've got my -1 over e up 3, -1 up 4, and e 2.7-ish up 5. So I end up with a graph that looks like this. We have a vertical asymptote. The vertical asymptote didn't change because we didn't shift to the left or right. So the asymptote's still x equals 0. But my domain, because I reflected, is now -infinity to 0, and my range is still all real numbers. And that's it. We're all done.